I have next to me Josh Bailey. He plays around with Tesla coils for fun, which is awesome, I think. So we're going to see a lot of lightning indoor, a lot safer than outdoors. So you choose wisely. So we should have video, we should have audio, and we're all good to go. So give a very warm welcome to Josh Bailey.
Thank you. It's very good to be here. Although I'm off to a strong start. I haven't even started talking and we already had an emergency. So I guess that's a good. Okay, so my name is Josh Bailey. Sorry, I'll come down a bit. I'm a software engineer for Google based in New Zealand. It's a very small office. My cat also helps. And for some hobbies, I play around with Tesla coils. And what I want to try and show you this evening is a bit of demonstration and discussion about trying to make coils perhaps a bit more musical. This is kind of based around, I think a lot of people have been playing music on coils for a while. And I think the level of technology has been, it's amazing that it works at all. So I made some friends with some musicians and we tried to push the state of the art a bit. So I'm not sure if it's a good musical direction, but we'll see what you think. So this system is so complex I can't even begin to explain it, as signified by this diagram. What I'll describe is a system where we have a musician, a keyboard controller, something called chime red, which is the synthesizer module, and then a Tesla coil. And as you can see, the musician is physically and logically isolated from the coil, because we don't want to kill the musician. That's bad form. And I'll just give a very brief demonstration of a couple of clips so you can see how it sounds. So I'm not sure how it's going to sound on these speakers, but I guess let's try. So I guess that worked. There's another mode which is also useful for protecting your car. Okay, you kind of get the idea. Thank you. So I'll try and explain a little bit further. So I'm a software engineer. I'm not a musician. What I've tried to do is go talk to some musicians and have them explain to me in small words that I can understand what things that they need, what abstractions they need from the control system to make it sound interesting and to actually use the coil as a synthesizer. And the first feature, actually, just to call out here, what I'm doing is, if you don't remember anything else about the presentation, the synth module is very, very carefully and precisely controlling the amount of power going into the coil from moment to moment. This is really, really, really important. Put too much power or get it wrong by a millionth of a second and there's running and screaming. Hopefully some from the audience or the musician. And not enough, and you don't get these interesting audio effects. So I'll explain a bit more in detail what those are. Okay, in this next little clip, what we did is try something a little bit different. When one coil is not enough and two is too low, you need 3 coils at the same time. and why not add a robot drummer and a robot bass player? So in this performance, we tried to get all these robot instruments to play together. We had some problems. The drummer did catch on fire. We just noticed this during a practice session. The coils jammed the robot's controller, so it jammed hard on, and the actuator caught on fire. That was a bit sad, but the robot bass player survived kind of okay. So this is a composition by a friend of mine called Jason Long in New Zealand, and the bass player was built by my friends James McVeigh and Jim Murphy. So I'll just play you a little snippet so you can kind of see them all working together, and if we have time at the end, I'd be happy to play the whole clip. Okay, what you're looking at first, just before I start, is the robot bass player. So it has 4 strings there. You can see an actuator there that rotates the picks, and there are fingers that travel along the slides there, so it can play. I've got to say, while I'm proud of the coils, I'm really envious of the robot bass player. It does tend to try and wander around the room as it plays. It's quite vigorous. Okay, a brief foray into Tesla coil theory. So just a summary of what I'm going to talk about. So what do I mean by music? So first thing is, as I mentioned, I'm not a musician, so I don't actually know what I mean by music. I'm just trying to make some interesting noises, so I hope they're enjoyable to you. Some more demonstration videos of some individual effects so you can hear exactly what's happening. Just a very brief discussion of how coils actually make these various sounds, and some interesting things that we observed having the system interact with its environment, put it that way. What the musician is able to do via the MIDI protocol, which is a standard protocol for controlling musical instruments, and some future developments, including a prototype vocoder. So I'm not ready to show you that yet, but we have been able to make the coils speak, which is extremely disturbing to be around. Okay, and yeah, so just to highlight, I consider myself an instrument maker, and I'm very keen to hear from musicians or other instrument makers, or anybody on suggestions or things that could be made better. Okay, because I'm a software engineer, I get into a little bit of hardware, and here's the first problem that confronted me in this project. This is my idea of a user interface. This is the gate controller that goes very near the coil itself. As you can see, it's extremely complex. You have one switch for arming and safe. There's a light to tell you if it's armed, and there's another light to tell you if the coil is firing. But probably if you're close enough to see that light come on, then you'll probably see some other lights before you go away. Now, can you see here, there's a fiber optic cable here, and this is obviously very important to keep the coil electrically isolated from musicians or anything around. Most musicians have to deal with ground loops at some point in their lives. Here we don't really want to include a high voltage loop as well. And yeah, just to really show you, I'm not a hardware expert. So this is or was a homemade gate driver for a coil. And this did actually work for several seconds. There was a chip there that kind of went away into a different universe. Didn't come back. I actually kind of impressed that it's just gone. Like, it left some of the legs behind. So yeah, I have no business going near any of this, but that doesn't stop me. And here's actually another, I have to acknowledge a very good friend of mine, Patrick Hurd. So Patrick and I built a very large coil called Pyramida, which is 20 kilowatts. So I have three-phase power coming to my house, which is very convenient. And Patrick and I decided to make a coil to use that. And it runs a bit hot, so he water-cooled it. And if you're interested, there's an article on Hackaday, which is quite interesting to read by itself. There's some advanced technology there. As you can see, there's like a kind of a plastic water reservoir there. Some fans. We ripped off a large computer cooler. Seems to work pretty well, though I don't really like to go anywhere near it when it runs. Okay, the sound itself. So what you're looking at here, this is a still of one of the coils playing in the videos I'll show you a bit later. So this is a very hot arc. The arc is actually stopped, but it's actually set a lot of component gases and things in the air on fire. And it's made quite an interesting visual effect, which was something that we were going for. Now, of course, this is something we don't want to happen too often. That means that we're switching a lot of power in there. That's pretty stressful on the components in the coil. So this is actually one of the key design elements in the system. Coils of this design handle peak currents of many thousands of amps. So it's important to have a way to keep that down. And the coil makes its noise by explosively heating the air. So very, very rapidly heating the air as the arc passes through it. And we're controlling the sound or controlling the notes that it plays by just choosing exactly when and for how long and over what period of time to add power to the arc. And there's also some many non-linear things as well. The arc will move around as the air heats, as things come into contact with the arc. And we had also explored making a machine for the coil to play with a bit to change the sound of the arc. So we haven't got too many results on that yet, but that's a topic of active research. So again, I know I keep saying I'm not a hardware engineer, so here's one of my typical circuit diagrams, how a coil works. I'm sorry, the person is not to scale. So this one is actually of a perimeter. In Tesla coil terms, it's called a offline Tesla coil. There's a big IGBT there, essentially a big transistor which controls the power. This was quite interesting because it's about as large as a brick. Can handle a peak current of 10,000 amps, which we do actually use, and requires that I have an export license. So that's stuck to my refrigerator, which says that I promise not to make WMDs or anything else without the prior permission of Mitsubishi. As long as Mitsubishi gets a cut, I guess it's okay. So the key thing to look at here, right in the center is the transistor which controls power. And there's a box down there, gate driver. And this is where most of the magic is deciding exactly when to turn that transistor on and off. And in this case, it's going on and off maybe a few thousand times a second for maybe 25 to 35 microseconds at a time. So not very long at all. Oh, and I'm feeding it with in our case, a 20 kilowatt, 1,000 volt power supply. So yeah, just kind of in summary, to produce the sound, we need to control the power. We choose exactly when and for how long to turn the power on. And the thing that makes it actually interesting is you have to be very careful when you're combining multiple notes, multiple waveforms. You can have a chord of death, just by having the musician hammer down all the keys, you could blow the system up. So the synth module's been specifically designed so that will not happen. And that the sound is consistent as possible, while also using the least amount of power and being as gentle in the components as possible. So I did, in a very early prototype with this, connect a guitar to it. I kind of bypassed a lot of these things. I thought, okay, this is going to be great. I'll just do a quick test. So I'll play Owner of a Lonely Heart on there because I'm old and from the 80s, so that's fine. but I'll play a couple of bars and then I'll video it. And I played a couple of bars and bang, the coil blew up. The power supply kind of left its case and went all across the room. And there was lots of gnashing of teeth, and I couldn't even look at it for 6 months. So that was a very good learning experience. Okay, so this leads to the system called Chime Red, which is the synthesizer module that enables all these audio effects. So I'll show you some demonstrations on some of the effects it enables. Oh yeah. So why have this magic box at all? So from the musician's point of view, they don't want to know about high voltages or coils or duty cycles or any of that stuff. They just want to be able to have a great time and turn some knobs. So that sounds like fun. So how do we do that? And also, actually, by the way, I tend to use Ableton, which I understand is actually written in Berlin, which is kind of cool. So I apologize if somebody is in the audience from Ableton. So I had a kind of negative experience. Occasionally, we'd have some compatibility problems, and I'd be pretty certain that Ableton was the cause. So I would log a bug with Ableton, and they'll say, "Oh, what kind of synthesizer are you using?" And I'm like, "Oh, it's a coil." And they're like, "Did you try rebooting it?" So I'm like, "Okay, I'll reboot the coil." It still does the same thing. Okay, so just brief summary on something called MIDI. MIDI is a very simple serial cable style protocol. It's traditionally how it's done for connecting things like keyboards and synthesizers together. So it's just a way that we can provide some isolation between what the musician is directly controlling, what they're touching, and what's happening at the high voltage end. So it's very, very simple. It's basically it runs at about 33K, and you send bytes to say, start playing a note, stop playing a note, do something to a note like change its pitch, or change some function inside the synthesizer itself. And traditionally it's over a little 5-pin DIN cable. It can run over USB and other things though. So the main point of this is that you can actually use any MIDI capable system, any keyboard with this, and it should work just fine. All right, so to be musically interesting, my musician friends told me that they need some things. So the first thing is they need to be able to play many notes at once. And if you look at a lot of the coil controllers that you can buy now, they often have like maybe one note, or sometimes they can play 2 notes, so you can have both the notes. It's pretty advanced. But people really need some much more than that. The next thing is they say they need is controlling, if you like, to speak very loosely, the volume of each note, or very precisely the volume of the note as it's playing. So that's very, very important, rather than just playing at a fixed volume, which is what a lot of controllers do. Being able to change the pitch in various ways as it changes, including, if you're a musician, be able to map a low-frequency oscillator with different waveforms to it, maybe also some filters. And also being able to combine different kinds of waveforms together to give a more complex sound. So one of the videos that I first showed you right at the beginning, where we had a relatively small coil, but it was producing quite a rich kind of bass note. That's what we were doing, is combining the output of several oscillators together. So I'll show you how those work. Okay, yeah, and actually summarize the common limitations as seen in other controllers is no dynamics, maybe only 1 or 2 notes at once, and just one one oscillator per note, so quite just a simple tone. So we want to do better than that. Started in about 2012. We had a prototype called pipe organ that could do 4 notes at once. We started with no dynamics, but then we added some. And last year we got to Chime Red after learning a lot and blowing up some silicon along the way. So yeah, it's not very beautiful. This is the original pipe organ prototype, which now sits on my desk to stop papers blowing away in the wind. but certainly learned a lot from it. And actually what's inside there is basically just an Arduino. Chime Red, the new system, is an Arduino Due. This is just a regular Uno in there. Okay, so now what I'm going to show you, this system can do 16 notes at once. You can assign multiple oscillators per note and you can tune them. There's an FM synthesis mode, which is kind of exciting if you like some of these complex sounds that FM synthesis can give you. There are 3 LFOs with some features which I'll demonstrate for you. And you get very fine control of the dynamics. So you can control the volume over time in different ways. So what does all this mean? Okay. So I'm just going to play you a video of starting off with 1 oscillator per note, and then I'm going to add more oscillators, and then I'm going to move them around relative to the fundamental note. And so you'll hear the sound change. I have to admit that results in many hours with a drum machine and like a SID station downstairs in my house just making noises like that, trying to learn what to do with it. Okay, so another example here. In this case, I'm using a configurable low-frequency oscillator to change the sound of those notes again. So what I'm doing is adding the oscillator, changing its speed and its depth, and then also changing its waveform. So you hear it go from sine to triangle and also sawtooth. And it's kind of important because this allows you to simulate some drum sounds. So I have another video, if we get time to at the end, which shows the coil functioning as a drum machine. It's pretty. Thank you. I wasn't sure how that sounded, but you probably hear there's kind of like a scratchy, raspy sawtooth sound towards the end, which is kind of fun to play with. It also sounds quite a lot more interesting live. This is more harmonics. Okay. So another feature is having very high resolution pitch bends. So this is actually how my friend Jim did the car alarm simulation. He just went in with Ableton using the Ableton draw tool and just picked the notes that he wanted and then just very carefully kind of hand sculpted all the waveforms so they would sound the way that he wanted. I thought that was pretty nerdy and pretty cool. But it's actually quite a nice learning experience for me is how electronic musicians want to work with the instrument. Like they really want to get in and have this very precise control. So what does the hardware look like? So this is the front panel here. The system has evolved a bit more from that prototype that you first saw. So you have a nice key switch to be armed or safe, controlling the coil. It's a lot more difficult to push the wrong button now. The coil will detect various unsafe conditions and stop commanding the coil, so that's good. Along the bottom, there are three knobs there, and this allows you actually to control dynamically the upper limits and the amount of power that's being scheduled to the system. It also allows you to control the range of notes that the system is allowed to play. This is kind of important so that if you're playing around with a new piece of software, a new keyboard, that you don't accidentally hit a very high note or do something that involves a lot of power. You can be quite gentle. There's also a built-in signal generator kind of for testing, so you can send arbitrary waveforms there. And here's the connectors on the back. So apart from a fiber optic connection that goes to a dual resonance style coil, there's another couple of connectors which are over to the right, which are interesting. These are for controlling the 20 kilowatt 1 kV DC power supply. And how we test that is use MIDI to play a commercial oven element. So you could hit a couple of keys and bam, just drop a whole lot of power into this element. It's how we make sure that before we actually played it live on the coil that we weren't going to blow anything up, except for an oven. So controlling large amounts of power by just playing a musical keyboard seems very wrong, but that's what those connectors allow you to do. Okay, so there's a bit of an interesting side note here about why chime read is called chime read. So a friend of mine had to deal with IEDs when he was on patrol. So very early on, they gave his squad an IED jammer. It's just a GSM jammer called Warlock Red, which is not used anymore. And it's not used anymore because if you turn it on, it jams everything, including your own radio. So if something, it might stop an IED, but also stops you from calling for help if you need to. So people would never turn it on. And so this system is called chime read because coils are horrible interference sources. When we were first doing performances with VJs, they go to a lot of trouble to set up these nice projectors, these very long HDMI runs, which are great antennas. And I try and point out that I'm using a 20 kilowatt death ray, about 20 feet away, and they're like, no, that should be fine. I'm like, well, let's see. So we'll play a couple of notes and bam, 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 down, all go down the controllers. You will lose some fuses, and everyone is running and screaming. So there's some things you can do to minimize it. The controller itself, as you saw, is built into a metal box. It's kind of in a Tesla bomb shelter, but that's no good for everybody else. So in a lot of live performances now, we actually put the entire system in cages, and for very large performances, we put the musicians in a cage and the coils on the outside, just so there's some separation. Radio frequency just tends to get into everything. In my house, I have a separate RF ground installed. The network connections downstairs to upstairs are fiber optic. There's a separate 100 amp three-phase circuit that's specifically for coils, and everything's on UPSs and everything else. And sooner or later, things still get zapped. So pay your insurance. And this leads to a problem that was very familiar. I mentioned this earlier with Ableton. So one of the problems with MIDI is that it's an unacknowledged protocol. If you send a command, there's no way for the receiver to tell you that it got it. And this can lead to hanging notes. If you suddenly stop playing, something doesn't get the note off, and so the note continues to play. On a regular synthesizer, that's just annoying. On a coil, that's pretty bad. You have that thing continuously run. So there are fail-safes kind of built in the system to guard against that. And there's also a special Ableton mode that detects when Ableton has said something in the wrong order and just kind of silently fixes it up. So something I'm considering doing, and maybe as a side project, is because it's not just Ableton, it seems to be quite a common problem, is to have a MIDI rearranger box. Like MIDI comes in one side and it just has one light on it which says, there, I fixed it. Comes out the other end and things just work. But it's quite common to see on MIDI devices like a panic button, and all this is just to go like, oh, something's happened, push this button, make everything stop. And our controller, that's not good enough, so we have a system to detect when there's a hanging note and shut it down. Okay, So I think I've gone pretty rapidly through this. So I've got some other videos I can show you, but it'd be great to ask for your questions in a moment. But just before I do that, there's a paper on the system coming up in Texas in a couple of months. It was an interesting exercise to figure out how to cite America's Got Talent. I feel kind of a bit wrong by that, but that's apparently where we are. As a kind of a description of like the state of the art. But that goes into some further detail on how the system works. Better digital audio workstation integration, so we hope to make it easier. So at the moment, I just implement many things in the MIDI standard, but I want to make it even easier than that, so that you can configure an Ableton instrument, for example, and it has values in there that you can tweak and change very easily and automate. It would be nice to be able to have multiple coils from the same chime bred. When we do multiple coils now, each one needs its own controller. So it'd be nice to have like an orchestra of death and make that scale. It'd be kind of nice. And also, like I said, there's a PCM input module option. We can make the coil talk and blow a few fuses. So there's still some work to do, but I hope to be able to show you that in the future. So before I go any further, thank you for listening, and I'd love to take your questions if you've got any.
So, are there any questions for Josh? Come on, come up to the microphones. Don't worry. If you leave the room, stay quiet, please. Any questions? Just wave your hands at the microphones. I can't see you. Ah, excellent. On the left side, please. We can't hear you yet. Okay. Try again.
Yes. Okay. All nice videos and stuff, but I think most people here came like thinking, maybe we see some awesome lightning stuff in real. Okay, I could have thought earlier we have not enough power here and security and all that. So, but where can we see it for real?
I'm sorry to disappoint. Yeah, sorry, I wasn't able to bring the system with me. I believe there is a coil that someone has brought along about a block over that you can see. It's pretty cool. Please come visit me in New Zealand. Unfortunately, I'm not ready to quit my day job, but perhaps when I can, I'd love to be able to take some time off and bring some coils around the world a bit. At the moment, I need to build some road cases. They're quite hard to transport.
And what I've heard, there's at least one Tesla coil at the camp, so just put it on Twitter and somebody will guide you there. Yeah.
Well, thanks for the talk. Was there like some situations where it was really dangerous and you really get harmed, or fire and you nearly all get killed?
No, actually, everything has been very, very safe. Yeah, nothing has happened. So I have actually sat in a very large coil while it runs. A friend of mine has built a very large, this one's a 50 kilowatt coil, and I go sit in the toroid when it runs, right on the high voltage wire. So I sit at about 1 million volts, and you are down there at about, from my point of view, some strange negative voltage. So that's very strange for you, but I think I'm at 0. And that's kind of fun because you can poke objects out through the toroid, and you can throw lightning bolts at people, which is fun to make them scream and run away. But you also have to be very careful not to put any part of yourself actually through that, because the field will enhance off your body, and then you'll be very sad. So fortunately, friends of mine have been able to keep me pretty safe from doing things like that.
Thanks, awesome work, and keep going on.
Oh, thank you very much.
Thanks. Back here.
Hi, thanks for the talk. My question is, can you modulate the sound by changing the composition of the air?
Oh, interesting question. So something we have thought about doing, well, apart from giving the coil something to play with as it arcs, is also feeding it different compositions. So something that's quite fun to do is run a propane flame effect system next to it and let the arc interact with the flame. And we actually went and filmed this in high speed, and we saw some interesting things. So at about 1,000 frames per second, it looks like the arc is interacting with the flame, just hitting it. But if you really slow it down and look at it, it's almost like it pushes the flame down in the place where the arc hits. And I don't understand exactly what's going on there, but that suggests that something interesting is going on, and that maybe we can feed it some different substances or different gases and cause it to change. And if we can cause it to change in that way, then we may be able to cause it to change in a musically interesting way.
Very cool. Thanks. I guess we need the video on this one.
Thank you.
So you're bringing that next year, in 4 years to the next camp?
I think I'm detecting some kind of hint that I need to bring a coil next time. Thank you.
So we have one more question over here.
Nice setup. It's a bit hard to tell from the videos. How loud exactly is this?
Oh. What? Did you say something? What? Yeah, it's actually horrendously loud. So the smaller demo videos that I showed you there are kind of manageably loud, but the big coil is deafening, certainly over 100 dB. In fact, I'm not sure what my neighbors think. Like I live in a light industrial area, and when we run the big system perimeter, like it echoes off the hills. And I swear there's just people in the neighborhood, they're like, what is that? Like, we just don't understand what goes on. So it can be very loud, but generally, obviously, in music mode, we try and keep that down. So while the coil is certainly capable of putting out a lot of power, it's no good if you deafen your audience so they can't hear anymore.
So how low can it do a frequency, and did someone try using it as a subwoofer?
So this actually, you can go down to the lowest MIDI note. This is actually where we use it as a drum machine. So actually see if I've got a example of that. I have one doing a cover of Blue Monday, doing the drum machine for that. This one, it throws out very large, fat arcs, like bang, 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 that we change the power slightly so it's more of a snap kind of drum sound. So you can get it down that low, but bass notes are quite challenging because you can hear the points where the power is scheduled. So that's one of the first things for having multiple oscillators per note is to have, like, say, many things running each at 30 hertz or 60 hertz and have them all slightly offset to kind of richen up the sound. So the bass is better than I think a regular coil, but it could use some more work.
Cool, thank you.
Thanks.
So, are there any more questions? Well, if not, I would ask you for another closing round of applause for Josh, please.
Thank you.